Today we'll talk about the Reynolds transport theorem. I think you are all familiar with the notion that the Reynolds transport theorem is a bridge connecting the two important methods of studying fluids, right? Lagrange's method and Euler's method. So let's first write out the RTT. dB dt. Well, do you remember what the capital D over dt is? It's called the hydrodynamic derivative or material derivative. Mathematically speaking, this is just the total derivative, right? So it's just d over dt. We can divide this thing into two parts. Actually 4 parts, but we can combine 3 parts together to form a vector form like this. So this part reflects the property, some properties change with respect to time, right? But not its change in space. So this part will be called the local part. But this part does address to the property change in space. So this part is called the convective part. Okay. We have learned index notation, so we can write this thing into a index notation. It will be ui times d dxi, very simple. Okay, so let's get back to write the RTT. dB dt equals partial derivative according to t, beta rho dv and plus the cs. CV means control volume, and CS means the surface of the control volume, which is called the control surface. Beta rho ur n ds, where n is the unit normal vector of the control surface, and ur, the r here means it's the relative velocity with respect to the control volume, right? First, we see that the RTT, the form of RTT is a lot alike the form of the hydrodynamic derivative, right? So in a sense, they are actually essentially the same thing. So you can bear in mind that notion. Also, what's the B and beta here? Well, B is just some property of the fluid, okay? And beta equals the B over its mass. So it's like a specific, property of the fluid. Say if we have the capital B here is mass, then the beta here will just be 1. Or if the beta here will be, say, momentum, that is mv, right? And the beta here will be dmv, dm will be just v, the velocity. Okay. So a third thing, we see that on the left-hand side, actually, we are speaking in a Lagrange sense, right? Well, on the right-hand side, we are speaking in a Euler sense, which means in the left-hand side, we are focusing on some definite fluid particles, right? Just this, let's say we are focusing on this part of the fluid. But on the right-hand side, what are we focusing on? We are focusing on control volumes. So we fix a volume in the space, and we are just focusing on this box, right? I will talk about it soon.